All right, let's start by looking at this question here. This is what 4.6, number 11 on the homework, or this version of it anyway. So we have a concentration of drugs in a patient's bloodstream, excuse me, T hours after injection is given by this formula. It is a rational function. It's got a polynomial on top and a polynomial on the bottom. What is the concentration of the drug after an hour and a half? Okay, so that's just us taking that hour and a half and evaluating that function C at 1.5. So whatever 30 times 1.5 divided by 66 plus 1.5 squared is, that's going to give us some value. Okay, that value is going to be the concentration after an hour and a half, should be something positive. And let's say on one at 0, just 6, it'll be some value, some nice positive value. So that shouldn't be a problem. We get to B, how long does this drug stay in the person's bloodstream, assuming that the drug is out of the patient's bloodstream once the concentration has decreased to 0.5%. Okay, so what does that all mean? What are we being asked here? Well, most of this section has to do with knowing how these functions behave. So if we look at this 66 plus t squared, if we look at this rational function, we should be able to determine any x-intercepts, any y-intercepts. We should be able to determine if there are any vertical asymptotes, and that's vertical asymptotes are going to, well, we'll talk about that when we get to vertical asymptotes, and horizontal or slant asymptotes. And horizontal asymptotes and slant asymptotes talk to us about end behavior. So it's going to talk about what's happening in this function as time goes on. So we've talked about some of these things. You've done some reading on some of these things, but in general, if we want to find x-intercepts, we let x equals 0. So if we let x equal 0, we're going to get C at 0 equals, well, 30 times 0 is 0 over 66 plus 0 squared is 0. So we get 0. So that means this thing has an x-intercept and, frankly, y-intercept at 0, 0. Okay, in general, when we want y-intercepts, we let y equal 0. So we have 0 equals 30 times t over 66 plus t squared. So fractions equal 0 when their numerators equal 0. So when 30t equals 0, which means when t equals 0, as long as that doesn't also make the denominator 0, but it clearly doesn't, it makes the denominator 66. So that x and y intercept happening at the origin. Great. Vertical asymptotes. Where do vertical asymptotes happen? Vertical asymptotes happen when your denominator is 0, or at least they have a potential of happening when your denominator is 0, as long as it's not also a 0 of the numerator. So we let the denominator equal 0, so we get t squared equals negative 66, and we know t squared can never equal a negative. So no vertical asymptotes, no vertical asymptotes. All right, not the most exciting so far. Horizontal asymptotes, well, horizontal asymptotes are an end behavior argument. So we look at the degrees. We have a degree 1 on top, a degree 2 on the bottom. So the denominator has a stronger degree, which means our end behavior is going to have this function heading off towards 0. So as t heads towards infinity, this concentration value heads towards 0. So what do we know is going to happen? We know it's going to fall this way. And if you were to graph this whole function, you'd see it looks something like that. Notice no vertical asymptotes, no other x or y intercepts, and that leveling off, that horizontal asymptote at y equals 0, or in this case, I guess c equals 0. So when we're asked how long does the drug stay in someone's bloodstream? Well, according to the model, it stays in the bloodstream forever. But of course, in practice, as soon as it gets less than a certain amount, it's essentially gone from the bloodstream. Essentially, I mean, literally, as long as it's less than 1 molecule of this drug, then it's gone. So once the concentration has decreased to 0.5%, so we'll just look at wherever 0.5% is, so 0.005. That 0.005 is going to come up twice, once on the way up and once on the way down. So we want this value on the way down. How do we find that? Well, we just set this thing equal to 0.5. I guess it would be, if that concentration is in percent form, it would be just 0.5. Yeah. Concentration. Yeah, it's automatically percent. Okay, so we just got to set that equal to 0.5. Well, that's going to equal 30t over 66 plus t squared. So multiply both sides by 66 plus t squared times 0.5 equals 30t. And here we have a quadratic. That's going to be, what, 33 plus 1/2 times t squared. Ooh, forgot my key. Hopefully you don't mind me going to fractions there. Decimals are a pain. So if we set this all equal to 0, 1/2 t squared minus 30t plus 33 equals 0. And I don't necessarily like doing things like this, or factoring or quadratic formula or anything like that with fractions in there. So I am going to multiply by 2 just to make this easier. That's going to give us t squared minus 60t plus 66 is equal to 0. And then we just have to solve that. Now, it'd be nice if it was factorable, but it doesn't look factorable. And frankly, I wouldn't expect it to be factorable. I don't say anything nice factorable. So throw that into the quadratic formula. We know the quadratic formula will give us 2 answers. One of those answers will be that first value on the way up. The second answer will be that value as the concentration falls. So that second answer as the concentration falls is what this question is looking for. Now, one of the issues here is, how do we know which one of those values to look for? Well, that's one of the reasons why I wanted to talk about, and why your section talks about, all this end behavior argument. We could certainly, and all these intercepts and vertical asymptotes and stuff, we could certainly have solved this quadratic without knowing any of that, but we wouldn't have known how to interpret our answers. Knowing what the end behavior is, knowing what the overall behavior of this function is, gives us a sense of, okay, not only how's this behaving overall, but which one of my answers is meaningful in what way. So how do we know that we are not caring about that first answer? Well, as soon as we have a sense of how the graph behaves, it's clear that that's not the answer we're looking for. We're looking for the answer as it falls. So even if we have really strong mechanics and really strong graphing skills and really all those skills, being able to look at a function like this and determine, where its asymptotes are, what its end behavior is like, is really informative to the other decisions we're going to have to make. Okay, real quick, I want to look at doing one of these backwards. I don't know why that copied that twice. Oh, well. So we're asked to write an equation for the function graphed below. Well, let's look at what we know about this function. We know it's got an x-intercept at x equals 2. We know it's got a y-intercept at y equals 2. So the coordinate 2, 0 is the x-intercept. The coordinate 0, 2 is the y-intercept. We know it has vertical asymptotes at x equals -2 and x equals 4. And it looks like, from an end behavior perspective, it looks like this thing's limiting to 0. So it looks like as x heads towards both positive and negative infinity, it looks like this function is heading toward 0. It could be heading somewhere else, but it looks like 0. So what does that mean we know? We know x-intercepts are caused by zeros of the numerator. So that means x minus 2 is a factor, I'm going to say on top. And can't be a factor in the denominator, or it wouldn't be an x-intercept. We have a y-intercept at 0, 2. Okay, that means whatever our function is, when evaluated at 0, we had better get 2. Oops, sorry. Let me write that better. Our function, when we evaluate it at 0, we better get 2. Hopefully that'll just happen naturally, but it is something we have to make sure happens. Vertical asymptotes happen at zeros of the denominator. So x plus 2 and x minus 4 are factors on the bottom in the denominator. And not factors of the numerator. And since the horizontal asymptotes happening at y equals 0, with functions heading towards 0, we know the degree of the denominator, the bottom, is higher. Now we got 2 factors for the denominator, so that'll make it a second degree polynomial if we don't add anything else, and a first degree polynomial on top if we just stick with that factor x minus 2. So the degree of the denominator will naturally be higher if we just go with that. So looks like we're going to be pretty safe here. So that means we have x minus 2 in the numerator and x plus 2 and x minus 4 in the denominator. Now, is it possible we have other factors? Yes, but let's say, for example, if we had, I'm going to go with x plus 1 in the numerator. Well, that x plus 1 in the numerator would want to make an x-intercept at -1, but it doesn't on our graph. So if it was in the numerator, it would also have to be in the denominator, and it would make a little hole in the graph right there. Now, it's possible that there is a hole there and we just don't see it. But essentially, why would we make up that there are holes in here? We talked about this when we were doing polynomials. We said make a polynomial of minimal degree. we could frankly put as many factors as we want, because they would essentially just cancel, right? If you put x plus 5 over x plus 5, the fact that they cancel means you don't get an x-intercept, you don't get a vertical asymptote. All we get is a little hole there on the graph. We don't see a hole. We have no reason to think there is a hole. So why would we put these extra factors in? I would say don't. So there could be extra factors, we don't know. It's also possible that there's some constant. You remember that constant when we were doing polynomials. That constant there is going to make this more or less stretched out and is going to affect what that y-intercept is. So the only reason we want to know that y-intercept is to make sure we get what we think we should get. So what do we know? We know that f at 0 is supposed to equal 2. So let's see if that happens or if we have to do anything to mess with it. Excuse me. So if we plug in a 0, we get a times -2 over 2 times -4. So that's going to be a times, those are going to cancel. A over 4 is supposed to be 2. So a has to be 8. Okay, so we're going to have an 8. So our final function ends up being, and hopefully you remember doing that when we did polynomials. Our final function f of x is going to be 8. You can write that 8 out front too if you want to, times x minus 2 over x plus 2 times x minus 4. So play with those. Hopefully this is helpful. If you have some other questions you want to look at, let me know. We can look at them on Monday. What's today? Friday. So we can look at some of those on Monday if you want. But let me know how it goes. I'll talk to you later.